Hello, welcome to Arbind Singh Academy. We are discussing matters in our surrounding, and this is lecture number 2. In first lecture, we had discussed about the matter, what is matter indeed, and what are their characteristics. In this lecture, I am going to discuss some more about the physical characteristics of matter with some examples, some experiments, and just creating some fundamental concept about the matter. So without wasting time, just write here that few questions are given in your book NCERT that we are going to discuss first, because you have understood what is matter and the physical characteristics of matter as well. So we have learned that matter is, just have a quick revision about this, because it will help you to understand. So I am just discussing that what we have learned the previous lecture, and in previous we have learned that matter is something which occupies a space and having mass. So on the basis of that, there is a question that which of the following are matter. The first question here, it is given that which of the following is matter. Following are matter. Which of the following are matter? This is a question, and the things which is given here: a chair. Is it matter? Chair. Air. Love, and a smell. Hate, right? And there is some other thing. We can have some other items as well, like hate, almonds, right? Thought, and cold is there, and lemon is there. Water, and a smell of perfume. Perfumes. Which one of them is matter and why? So as per definition of matter, we can say that matter is something which having mass and occupy space. Chair space? Yes. So can we say this is a matter? Yes. This occupy a space and having some mass as well. Air occupy a space? Yes. And having some mass? Yes. Love. Do you think love has some mass? Can you say that I have 2 kilo love with my father? Can you say 3 kg love I my girlfriend? No, you can't say like that. So love do not have mass. They do not occupy space also. So this is not a matter. Big no. A smell. A smell is what? A smell of something coming from a gaseous state. For example, something is rotten and a smell is coming. Or some chicken is made in your kitchen and you are sitting in your drawing room and you are just saying, Mom, are you making chicken today? How you come to know? Mom is making chicken in kitchen, but you are sitting in drawing room and you are just saying with the smell that, Mom, are you making chicken today? Chicken has a special type of a smell when there is a fragrances, and our olfactory system just detect the smell, and on the basis of that you can say that there is something. So something is being made, some specific item is being made in kitchen. So here some smell is being detected, that is some particles which is coming through air and detected by our olfactory system, and that is why we can say that there is this is a matter, because some particles are moving and coming to your nose or olfactory system, where you can smell this. There is a chicken is being made in our kitchen. चिकन इज मेड इन आवर किचन। वाह क्या बात है। तो ऐसा कुछ होता है कि आपके जो स्मेल है इसमें कुछ ऐसी फ्रेग्रेंस होती है, जो खुशबू होती है, वो धीरे धीरे ट्रैवल करके थ्रू एयर वो पार्टिकल ट्रैवल करके आता है, और आपकी जो सूंघने की शक्ति है, जो आपकी ऑल्फैक्टरी सिस्टम है, जो ऑर्गन्स है, वो उसे पहचान लेती है कि किस चीज की खुशबू है और आपके घर में क्या बन रहा है, और इससे आपको पता चल जाता है। इसी तरह से कोई परफ्यूम लगाए, तो परफ्यूम लगाए तो कहते वाह क्या बात है, क्या खुशबू आ रही है। खुशबू कहाँ से आ रही है? तो यहाँ से आ रही है, इनके बॉडी से आ रही है, इन्होंने परफ्यूम लगाई, इन्होंने डिओ लगाई, इन्होंने ये लगाई, तो इसके वजह से हमें खुशबू आ रही है, कुछ आ रही है। और क्या आ रही है? तो गैस आ रही है। और गैस में क्या होता है? जो गैस में होता है, जो फ्रेग्रेंस हो रही है, वो गैस के फॉर्म में आ रही है। और वो गैस जो है, बेसिकली क्या है? गैस एक मैटर है। सो दैट इज व्हाई स्मेल इज, यस, दिस इज ए मैटर। Smell is matter. Hate. Hate, again, love and hate are not matter. Why not matter? A big no to hate. Hate is not a matter, because you cannot hate you 2 kg. I hate you 3 kg. You are not saying like this, right? So there is not mass nor a space. I have a huge hate. I hate you too much. Usually people say, but too much is also not the uh, not the unit in which you can measure the mass of hate. You know, so that is why hate is not a matter. Almonds, yes, there is a mass and it does occupy space, so this is a matter. Thought, again, thought is something coming in your mind. Yes, coming and going, thought is there, but it do not possess any mass or occupy a space, so that is why it is big no. Cold, cold is a state of substance in which there is a state of substance in which neither their mass increases nor their something increases. Cold is a state of substance that cannot be say that this cold is a matter. It is a status, and it is not going to change anywhere. When substance become cold, it is not going to change any state of the substance. So that is why that is neither mass or space. Although there is something where it become colder and their space is increases, like water when it become ice, their volume increases. But even though cold is cannot be considered as matter, because they do not possess any mass. So that is why cold is no, it is not a matter. Lemon, yes, it has mass and uh, occupy space. Water, yes, it is mass. A smell of perfume, yes, because our olfactory system can detect it, and this is will the fragrance comes from in form of gases to us, which will reach to our nose, and we are able to detect the fragrance of particular perfumes and say yes, this one is a perfume. Okay, so this is the first question which I am going to discuss, which I have discussed right now. Now the next question is, so there is a next question. Give the region of the following observations, and what are those observations that, as I told you, that when chicken is being made in your kitchen, and if you are sitting in drawing room, even you say that chicken is being made in kitchen by mom, or in some nearby houses, अगर आपका पड़ोसी भी चिकन बना रहा है या मछली बना रहा है, तो उसकी खुशबू देख के आप कहते हैं कि अड़ोस पड़ोस में कहीं ना कहीं मछली बन रही है। ठीक है, कोई भी खाना हो सकता है, not only chicken and fish, but other items also. Even biryani is being made, and veg biryani, then also you will come to know that somewhere this is being made. Why? This is because they are hot, and when they become hot, then their fragrance comes travel lot of distance, because the kinetic energy of the particle will increase when it become hotter. ये हमने पहले भी बताया था कि काइनेटिक एनर्जी व्हेन टेम्परेचर इंक्रीजेस, काइनेटिक एनर्जी ऑफ मैटर विल particle will increase, and therefore because kinetic energy of particles will increase, and therefore they will move faster, and motion become faster, and since motion become faster, so they will reach to faster to the nearby place, and therefore hot items or hot food even reaches a smell of hot food reaches to us faster, and when they are cool, when the cold food are being made, for example, cold coffee is being made in your kitchen. Will you say in drawing room that cold coffee are being made? No, because it cannot, smell cannot come to you. When you will go to that there in kitchen and you will see very close to it, some very good smell will come to your nose and you will be able to understand that this is being made. So here, because of the answer of this question is, when the things become hot, temperature of any substance increases, the particle of the substance through which of which it is made of, the kinetic energy of those particles are increases, and therefore motion of the particles will be faster, and hence it reaches quickly to the nearby places, and one can detect it from large distance even. But opposite to that, when the substance become cold, then the particles of the substance has a lower kinetic energy and it has slow motion, so it cannot reach to the larger distance easily, and person has to go too close to it to smell it or realize it. Anyway, so I hope you got it. Now the third question is there. So answer is due to increase in kinetic energy. Let me first write the answer of the previous question, then I'll take up the next. Increase in kinetic energy of particles, particles, right now, energy when temperature is increased, in hot food, temperature is high and therefore. So this is what I can say about this. I hope you got it right now. Now let us see the third question. So third question, this is time to think. And third question, it is said that a diver is able to cut through water in a swimming pool, right? Which property of matter does these observations show? Which property of matter does these observations show? Does this observation shows, right now? So this is the question, and we will so in this, to answer this question, we can say that water is a form of liquid, and we know that properties of matter we have studied, and in that we have learned that there is an intramolecular space between two particles. So there is a space, and a space is between two particles, and that is why they can be separated. Right now, when they are intact with each other, closely packed with each other, then it is difficult to separate them. But when there is a loosely packed, then you can easily space them from one another. You can place your chair from one place to another place, and here water is, the particles of waters are loosely packed. There is a weak force of attraction between them, and that is why it is easy to separate them, one particle from another particle. So particles can be separated because there are intramolecular space between them. So this is the property can be answered for this question. So solution is the able to cut through. A diver is able to cut through able to cut through water as there is between the particles of matter, that is water here, water right now, and there is weak force of attraction between the particles. I hope you got it right now. So this is what we have to answer about this question. Now there is a question number 4, and that question I'm going to take on here. Question number 4 is there. So fourth question is what? They are saying that what are the characteristics of particles of matter? What are the characteristics of particles of matter? So we have discussed. I'm going to answer this question, that what are that? There is first property, you can say there is a space between, there is a space between the particles, the particles of matter, you know, there is a space between particles of matter. Second one is particles of matters are continuously moving. Particles of matter are continuously moving, right now. This is the second property. We can have second property. And the third property is that there is a force of attraction. There is a force of attraction. There is a force of attraction between the particles. That is, particles attract each other. Particles attract each other. Particles attract each other. Right now, this is what. And the next property is that we can say these are the three, but fourth one is, and the one particle can diffuse with another particle. So that is also a property. One particle can diffuse with another particle. One particle, one type of matter, one particles of one type of matter can diffuse with another. Particles of one type matter can diffuse. Diffuse means intermix with another. Let me discuss with some examples in which we can show that how the diffusion takes place and how it will be proved here. So suppose you have in this on this screen, you have some diagrams here, and these diagrams, what they say about all, that is water. In this one, particles of water magnified millions of times. If you will find millions of times magnified means क्या होता है, बहुत बड़ा करना. अगर लाखों बार बड़ा करें पार्टिकल्स को किसी ऐसे इंस्ट्रूमेंट से, तो हम पार्टिकल्स के जो वाटर के पार्टिकल्स हैं वो ऐसे आपको दिखेंगे. इस तरह से दिखेंगे। इस तरह से दिखेंगे तो ये जो गैप है, देख रहे हो, एक पार्टिकल यहाँ है, एक पार्टिकल यहाँ, एक पार्टिकल यहाँ, एक पार्टिकल यहाँ, तो ऐसे इनके बीच में गैप्स है ना, ये गैप्स है। तो इस गैप में जब हम कोई दूसरा चीज डालते हैं तो ये इस गैप में ही आ जाता है। ये जो है आप स्पेस देख रहे हैं, तो इनमें गैप्स है। इसमें आपने थोड़ी सी सॉल्ट डाल दिया, ये सॉल्ट आपने डाल दिया इसमें, तो क्या हो गया, सॉल्ट डालने से क्या हुआ कि ये सॉल्ट इसके अंदर आके इसके बॉटम में कलेक्ट हो गया, जमा हो गया। सो व्हेन यू ऐड अ salt 1 spoon salt in it, and then what will happen that this salt will come to the deposited to the bottom, and now it is precipitated to the bottom, but slowly when you stir with a glass rod, say this is a glass rod, so if you stir with a glass rod, then this particles of salt, this crystal of salt comes in between the space, and they are here, they are going to be this place, these are the particles, and they are filling these gaps. What the gaps here looks like, in between the gaps they are just accommodating, and it is invisible. What here visible was earlier in the bottom of the glass or bottom of this beaker, then that is not visible when you stir it. So in between the space of the two particles of water, the particles of salt are dissolved, and that is called the diffusion. So they are dissolved here completely, and now it is not visible even with naked eye or any microscopic vision easily. But when you have a very fine microscope in which you can see, you will see the different type of particles are there, and between the gaps of these water molecule or particles of water, there is a particles of salt. So it means when we dissolve salt in water, right, when you dissolve salt in water, the particles of salt get in the space between the particles of water, and that is why this process is called diffusion. When one particle get into another particle and diffusion takes place, and here what will happen that water is completely get salt crystals in between the space of two particles of water. So this is what happened. With this activity, we can conclude that what we can conclude, conclusion is there. Conclusion is what? Conclusion is there. Conclusion that there are a space between first. There are a space between two particles of water. Two particles of water. Two particles of water, right now there are a space between two particles of water, and that space is so much that the molecule of, and when sugar, salt or any other soluble item is mixed in it, they are placed in between the gap, in between the space of two particles of water. Two particles of water. I hope you are getting right now. So this is what happened here, right now, and they are, when they are completely mixed, when they are completely mixed, the particles of sugar, salt, etc., are placed thoroughly, placed thoroughly, thoroughly. The thoroughly means throughout the solution, throughout, placed throughout, throughout or thoroughly, same thing. Okay. Let us think of how this small this particle is. You can take some experiment from your household items. You can take a bucket of water and just put 2 or 4 drops of Lysol or Dettol, and the bucket of water is completely, the color of that is slightly changed, and the floor of your house, 3, 4 room, 4 room, 5 room, all are being wiped out with this water in, which contains some Lysol, drop of Lysol, and you can feel the fragrance of this Lysol and throughout the room, everywhere, in every room, every place, because this 2 drop contains millions of particles which are being dissolved in complete bucket of water, 4 liter, 5 liter or 10 liter even. And this few drops of Lysol or Dettol even, in hospitals you have seen that everywhere there is a smell of Dettol. Why this is so? Because they are put Dettol into the water, and with that water they wiped out the floor of the hospitals, and therefore a smell of the Dettol you are experiencing while you are moving in hospitals. So this particles, just 2 drop or 1 drop, contains millions of particles which are distributed in the gaps of, in the space between the particles of water, right? So you may think of how small this particle is right now. You can have some experiment as well. You can put a drop of ink in water, on your shirt, suppose a drop of ink is there, and you are dissolving all these in bucket of water. You will experience that this small drop are completely dissolved in bucket of water, and the color of the water is changed. How? Over in a laboratory, you can experiment and you can have some same experiment in which you can deal with this, how this a small particle is. There is an experiment in your book which is given, and you can do with other items as well, but let me discuss that one. You can take 2-3 crystal of potassium permanganate, and in 100 ml of water, if you drop it and stir it nicely, like here, 2-3 crystal of potassium permanganate. This crystal is nothing else but they are potassium permanganate, right now, permanganate, potassium permanganate, and they are being just put into the water, 100 ml water. This is a 100 ml water, this is a water, and if they put into that, the color of this whole water 100 ml is changed. 2-3 crystals are enough to change and feel the gaps between 100 ml particles of water. So now take out of 10 ml of it and then put in another 100 ml of water. You will see the color is lighter, but it means what? These particles, what dissolve in 100 ml, and that is in 10 ml of that is being taken, that is 1/10 of that is taken, and again put in 100 ml, then this 10 ml is distributed in 100 times again. That 100 into 100 times they are distributed. Again 10 ml of that is being taken and put into another 100 ml of water. The light is lighter, color is lighter, but still they are dissolved throughout the solution. Again, if you take 10 ml of it and put in another 100 ml of water, they will be dissolved thoroughly and fill the gap throughout the solution. Even they become lighter, but the particles are so small that they can distribute even 100 into 100 into 100 into 100 ml of the water thoroughly. So you can observe it. This is 1 liter into 1 liter. That is 1 liter 100 ml into 100 ml into 100 ml into 100 ml. How is that so small that this can be one crystal or two crystal of potassium permanganate is distributed throughout the solutions, and even though it become lighter, it means their purgence are very less, very less, very less, lesser and lesser it is going to become, but throughout the solution they are distributed, and it means whatever the gaps are available in between the two particles of water, they are trying to fill them, and therefore the color of this become lighter, and throughout the solution the same color is visible, so you can imagine that how small this particle is right now. So particle is very, very, very small items, very, very small things, and that is I said earlier in the previous class that they are described as God particle now, and said that God particles is now discovered by and some experiment by Higgs boson. These are the two scientists, and they said that all the particles are made of it. But here we can just imagine that particles are very, very small, even what we may think that the particle could be, but that is smaller than that. So particles are very, very tiny particles. Even I given you example that even 2 drops of Dettol's in full bucket of water can be dissolved, and thoroughly the whole water it can fill the space between the molecules of water of whole bucket throughout thoroughly, right? Okay, here what is happened, 2-3 crystal of potassium permanganate, 2-3 crystal of potassium permanganate are dissolved in 100 ml of water, right? Then 10 ml of this is taken, 10 ml of the solution is put in another 100 ml of water, and so on. What the conclusion is? So we'll find the conclusion is what is conclusion? First, the particles, the color of the conclusion with observations, the color of water is becoming lighter with each experiment of further dissolve of particles in a smaller amount, right now. And it proves, this proves that particles are so small that it is distributed thoroughly throughout the space between particles of water, and hence their purgence is lesser. lesser, right? So this is what happened, and particles are so small that they are distributed thoroughly in the solutions. And I hope you got it, that particles are very small. They fill up the whole gap between the two particles of water, and therefore their presence become lesser, and hence it become lighter. So I hope you got it, and all these things what we have discussed today, you learned it and you understood it. I am taking some more time, not hurry to complete this topic, because it can be completed in quicker one or two lecture. But even though I want to give you the comprehensive idea to understand and build up your concept and understanding about the subject and about the chemistry. So that is why I am taking some more time than the usual time I am taking in the classes, because here you are experiencing the chemistry from your everyday life. I hope you got it, and thank you very much for watching this. Keep watching. God bless you. Okay, God bless.